Hey guys, here's the third review chapter, so let us get started, shall we? Number one, it says x is the midpoint of AB and AX and all this good stuff. I'm going to kind of key in on this stuff right here, so I'm going to do a little zoom, boom, boom, ba-doom, okay? So follow along with me if you can. So a lot going on here. X is the midpoint, so right in the middle of AB we have x squared plus x is ax, and we have this section right here is 8x plus 28. So we got to set these two equal to each other. We notice we have an x squared, so we're going to have to factor. So we're going to move everything over to one side. So subtract the 8x, subtract the 28 over, we end up with a quadratic x squared minus 3x minus 28. And we factor that down to x minus 7, x plus 4, which gives us our two answers of x plus 7 and x minus 4. Okay? We're not done yet. It didn't say just find x. It also asked us to find AB. So we have to actually go ahead and plug those back in and find the answer for both of them. Okay? So x equals 7. Oops, sorry about that. X equals 7. And x equals -4. So you just plug it back in. I'm going to let you actually just leave it like this for now, just because it can kind of get overcomplicated. Alright? Number 2. A and B are a linear pair, which means they add up to 180. A is 4x plus 12. B is 2x plus 36. Find x. So what we need to do, if they're a linear pair, we know they should add up and set equal to 180. So we set them equal to 180 here. And then we go ahead and subtract 48, divide by 6, and we get x equals 22. Okay. Number 3, C and D are complementary angles. And C equals 8x minus 12, and D equals 4x. So what we're going to do, like the one above it, is we're just going to go ahead and add them and set them equal to 90 because they're complementary. And if we do that correctly, we actually end up kind of getting this weird fraction thing of, oops, sorry about that, x equals 4, 14 over 22. We could reduce that to 4 and 7 over 11. Okay? So, there you go. Let's go with these ones. I'm going to zoom back out just because it's a little hard to move around. Okay. Alright, back out. Here we go. Which properties are being used? Symmetric, you can tell because they're just flip-flopping. Next one is substitution. We're substituting C equals 30 in for C. So I think that's changing. This looks like 2D. That's supposed to be 2D. This one's supposed to be 2D as well. So that wasn't supposed to be changed. My autofocus is supposed to be locked, but I don't think it was. Okay, so it should be locked now. Alright, cool. That was annoying. Reflexive is AB equals AB. And then transitive, x equals this, y plus 1. Then y plus 1 equals z, so that's x equals z. Transitive property, you could also argue that's substitution. Last but not least, subtraction. We're just subtracting 8 from both sides. That's how it gets down to 3x equals 12. Number 9, find all the missing angles. Well, we start with 126. We have parallel lines here. And so these two should add to 180. So 126 plus 54 equals 180. Once I got that, then I know that these two should add to 180. So that's how I get 126, and so on and so forth. So that's how I got all the interior. And then 54 and this would have to add to 180 because they're also supplementary. They're a linear pair. So that's how I got that. And same with 26, and over here, and over here. So all those are just kind of doing either consecutive interior angles, so these two are consecutive interior angles, and then these two are a linear pair. Okay? Alright. Number 10, find x and y. If lines A and B are parallel, I like to go ahead and block this off right here. If you notice, this and this are just going to be set equal to each other because these two, we could do corresponding angles by doing vertical angles first, but I like to just say, hey, they're alternate interior angles as well. Okay, so set them equal to each other, y equals 18. Then cover up the other side. Those are consecutive interior angles, so they're supplementary. So we add them together, set them to 180, and we get x equals 38. Okay, number 11. Let's see if we can zoom in again. I'm going to go 2, then I'm going to pull out. There we go. I think that will be just fine. Okay. Alright, so number 11, we want to find x and y. This is an isosceles triangle, so to find x, we're going to set these two pieces equal to each other. That's how I get x equals 4. And then to find the y's, well, this wasn't originally here as a 3y, but since we know it's an isosceles, base angles are congruent, so we can get a 3y down here, and we just add all the angles and set them equal to 180. So 3y plus 3y plus 2y equals 180, and that's how I get 22.5. Moving up, number 12. Number 12, finding x. These are a linear pair. Set them equal, by adding them together, set them equal to 180. You get x equals 26. Number 14. This is again an isosceles triangle, which means base angles are congruent. So we set them equal to each other. We get x equals 18. I love these. These are so nice. Just fly through them, huh? Okay. This one right here, again, isosceles triangle. We can set these two pieces equal to each other. If I do that, okay, set them equal to each other because they're congruent legs, and we get x equals 6. Okay, again, that's because these two legs are congruent. Number 16, is it possible for a triangle to have the following side lengths? We gotta just double check to make sure the two smaller are bigger than the largest. So 3 plus 8 is not larger than 12, so it's a no. 11 plus 11 is bigger than 18. 1 plus 2 is not bigger than 3. This should be a no. That was a mistake. My bad. Okay, they have to be bigger, not equal to, but bigger. 8 plus 8 is bigger than 8, so yes. Number 17, if a triangle has side lengths of 7 and 16, then the lengths of the third side must mean what? All you do is add and subtract them. If you add them, you get the high length. That means it can't be 23, it has to be less than 23. And subtract them, and you get 9. That's what it has to be greater than. Okay? So if we were to write it, it would have to be, x would have to be greater than 9 and less than 23. Okay? This next one doesn't have a number on it, but it says AB is equal to CD, which we have listed and marked right there. AB is parallel to CD, so AB is parallel to CD. Which triangles are congruent? Well, we also have BD is congruent, and then these two are going to be congruent by parallel. So we have side, angle, side. And so A is going to correspond with C, D with B, and B with D. CPCTC stands for corresponding parts of congruent triangles are congruent. When is it okay to use it? Only after you prove two triangles congruent by a postulate. And one of those postulates would be angle, side, angle, side, 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 angle, angle, side. Then we have side, angle, side, and HL. Alright, here's our transformation rules for over the x, over the y equals x. Our rotation rules, you should already have all these rules. If you need to pause this video and take a snapshot of it, you can. Okay? And then I'm just going to go through the answers of these. I'll just put them up slowly and then you guys can copy them. If you're confused, you can go over these in class. So just pause the video real quick to get those down. And then you can pause it there to get those down. And that's it.